Imagine a scenario where the actions of humanity are not just contributing to climate change, but are actually locking vast regions into a state of permanent drought. This is the alarming reality that a new wave of climate research is uncovering, particularly in the Southwestern United States. For much of the past 2 decades, the Southwestern U.S. has been grappling with a historic megadrought, a period so severe that it has pushed iconic reservoirs like Lake Mead and Lake Powell to record lows. The situation has escalated to the point where legal battles are breaking out over the dwindling waters of the Colorado River. But here's where it gets controversial. While the drought has traditionally been linked to natural climate patterns, new research suggests that human activities are playing a far more direct and significant role. The Pacific Decadal Oscillation, PDO, a climate pattern that typically shifts between wet and dry phases every few decades, has been a key player in the region's weather. Since the early 2000s, the PDO has been stuck in a dry phase, leading to an unprecedented drought. Historically, the PDO was considered a natural phenomenon, driven by unpredictable fluctuations in the ocean and atmosphere. However, a groundbreaking study published in the journal Nature reveals that this is no longer the case. By analyzing hundreds of climate model simulations, a team of atmosphere, earth, and ocean scientists discovered that the PDO has been significantly influenced by human factors since the 1950s. According to their findings, the PDO should have transitioned to a wetter phase by now, but instead, it remains locked in a dry cycle. This suggests that unless human-driven warming is curtailed, drought could become the new norm for the region. Understanding the science behind a drying world is crucial. For decades, scientists have known that warmer air can hold more moisture, leading to a pattern where wet areas become wetter and dry areas become drier. As temperatures rise, more moisture is drawn from the soil in arid regions, exacerbating drought conditions. While most climate models predict this general trend, they often underestimate its severity, especially over land areas. The consequences of prolonged drought are far-reaching. Ecosystems, economies, and global food security are all at risk. And this is the part most people miss. Drought is not just a temporary inconvenience. It can lead to long-term environmental degradation and economic hardship. For instance, severe droughts can reduce crop yields, increase food prices, and even lead to shortages of essential commodities like coffee, wheat, and beef. One of the biggest challenges in climate science is accurately simulating rainfall patterns. Rainfall is influenced by a complex interplay of large-scale wind patterns and small-scale processes like cloud formation. Until recently, climate models have struggled to provide a clear picture of how rainfall will change in the near future as greenhouse gas emissions continue to rise. Different models can produce widely varying predictions, making it difficult to plan for the future. However, the techniques used in the latest research are helping to refine these predictions, especially for North America and the tropics. By examining the historical pattern of PDO phase changes over the past century using an extensive ensemble of climate simulations, the researchers were able to isolate the human influences. They found that the shifts in the PDO were driven by an interplay of increasing warming from greenhouse gas emissions and cooling from aerosols, particles that block sunlight and are associated with industrial pollution. From the 1950s to the 1980s, increasing aerosol emissions from rapid industrialization following World War II led to a positive trend in the PDO, making the Southwest wetter and less prone to drought. After the 1980s, however, a sharp rise in greenhouse gas emissions combined with efforts to reduce aerosol pollution shifted the PDO into its current negative drought-inducing phase. This finding represents a significant shift in our understanding of the PDO and serves as a stark warning for the future. The current negative phase of the PDO can no longer be attributed solely to natural variability. It has been heavily influenced by human activities. Geological records from around 6,000 years ago during a period of high temperatures, show a similar temperature pattern in the North Pacific and widespread drought across the Southwest, supporting the idea that global warming can drive the PDO into a negative phase. The implications extend beyond the southwestern U.S. The past also provides clues about future rainfall changes in the tropics, particularly in regions like the Amazon. About 17,000 years ago, a major slowdown in Atlantic Ocean currents led to widespread shifts in rainfall patterns across the tropics. A recent study using computer models to analyze geological evidence found that this period saw much stronger drying in the Amazon basin than previously thought, along with similar patterns of aridification in Central America, West Africa, and Indonesia. These findings suggest that even a modest slowdown in major Atlantic Ocean currents could lead to a significant decline in rainfall, threatening rainforests, vulnerable ecosystems, and the livelihoods of millions of people across the tropics. So, what comes next? Drought is a growing problem, increasingly driven by human influence. Addressing it will require a fundamental rethinking of water management, agricultural policies, and adaptation strategies. Accurate drought predictions are essential, and recent advances in climate modeling offer hope. By using computer models in innovative ways and rigorously validating their performance against historical climate data, scientists can provide a clearer picture of the risks ahead. The outlook is sobering, but with better predictions, we can take more effective steps to mitigate the impacts of a drying world. Do you agree that human activities are the primary driver of the current drought in the southwestern U.S.? Share your thoughts in the comments.